All right, welcome back everyone. Today we're going to talk about solving exponential equations. And so in this section, you're just going to learn how to solve exponential equations. So an exponential equations are those that involve exponential components, right? So for example, something like 4 to the 2x is equal to 16. In this case, we want to solve for x. We want to figure out what x is. So to solve exponential equations, you're going to want to try to isolate the exponential component. Okay, this is not always possible, as you'll see in one of the last examples. Then you're going to take the logarithm of both sides. You can use common log, which is log base 10, or you can use natural log, which is ln log base e. I always use natural log. Then you can use the logarithm properties from the previous section to simplify and solve for x. Okay, so we're just going to try some examples here. First of all, we're going to start off with 6 to the 3x plus 5 is equal to 216. So we've got the exponential component on one side by itself. So the next step is to take the log of both sides. And like I said, I like to use natural log, so we're going to take the natural log of both sides. So the natural log of 6 to the 3x plus 5 is equal to the natural log of 216. Now the important thing to remember here is the natural log of 216 is just a number. It's just some decimal number. So we're just going to leave that alone. On the left-hand side, though, we have the log of something raised to a power. We can use the power rule from the last section, and the exponent will just become a constant in front. And so essentially we're going to take the 3x plus 5 and move it in front. So that we get 3x plus 5 times the natural log of 6 is equal to the natural log of 216. Now we want to solve for x, so we want to get that piece with x by itself. So to do that, we're going to have to divide both sides by the natural log of 6. When we divide by the natural log of 6, on the left-hand side, the natural logs cancel out, and we're left with just 3x plus 5. On the right-hand side, we get the natural log of 216 divided by the natural log of 6. If you put that in your calculator, you should get 3. We can then solve for x by just subtracting 5 from both sides. You get 3x is equal to negative 2. Divide by 3, and we get x equals negative 2/3. Okay. That was a somewhat simple example, because when we did this part here, it wound up being a whole number. Right? The natural log of 216 over the natural log of 6 is just equal to 3. However, that's not always going to happen. So let's try another example. Now we have 3 to the x is equal to 17. So we have 3 to the x power is equal to 17. Once again, we have the exponential component isolated, so we're going to take the natural log of both sides. The natural log of 3 to the x is equal to the natural log of 17. Using the power rule from before, we can take the x and move it in front as a constant. So that we get x times the natural log of 3 is equal to the natural log of 17. Then to get x by itself, we just divide by the natural log of 3. Now, the natural log of 17 over the natural log of 3 is not a whole number, but we can still find that using our calculator. And you should get x is equal to 2.5789. Let's try another example. The base, in this case, is 3. The base does not always have to be a whole number. So what if we have a base of e? So 4 times e to the 7x minus 134 is equal to 7825. Well, the first thing we want to do here is isolate our exponential component. And so we're going to start by adding 134 to both sides. And we get 4e to the 7x is equal to 7959. So we still want the e part by itself, so now we want to divide by 4. If we divide by 4, we get e to the 7x is equal to 1989.75. So let's move to the next slide from here. And now what we have is e to the 7x is equal to 1989.75. So just like before, we're going to take the natural log of both sides. But now on the left-hand side, hopefully this looks somewhat familiar to you. When you have the natural log of e raised to some power, remember the natural log of e to the x is just equal to x. So the natural log of e to the 7x is just equal to 7x. This is why I use the natural log every time. So now we have 7x is equal to the natural log of 1989.75. Which gives 7.595764. And then if we divide both sides by 7, we get x equals 1.0851. Finally, we can have two exponentials on either side of the equation. This is when we can't simplify it down to 1. But we can still use the same steps. This one just requires a bit more of keeping track towards the end. So we have 3 to the x power is equal to 2 to the x minus 1. Let's just start by taking the natural log of both sides. The natural log of 3 to the x, the natural log of 2 to the x minus 1. Using that power rule again, we're just going to move the exponents into the front as constants. So we get x times the natural log of 3 is equal to x minus 1 times the natural log of 2. Now we want to solve for x, but we have x in more than one term. So what we need to do is get x onto one side of the equation. So let's distribute in the second part, and we get x times the natural log of 3 is equal to x times the natural log of 2 minus the natural log of 2, or minus 1 times the natural log of 2. Let's now just subtract minus x times the natural log of 2 from both sides. And what we wind up with, going to the next slide, is x times the natural log of 3 minus x times the natural log of 2 equals negative natural log of 2. We can now factor the x out on the left-hand side, and so then we get x times natural log of 3 minus the natural log of 2. And then to solve for x, we just divide by what's not x. So we divide by natural log of 3 minus the natural log of 2. And what we get is x equals negative natural log of 2 over the natural log of 3 minus the natural log of 2. These problems are a bit more complex. In some cases on your homework, they will ask for exact answers in terms of natural logs. And so this is how you would write an exact answer. If you wanted a decimal answer, you would just plug that into your calculator and calculate the decimal. And so at the end of this lesson, you should be able to solve exponential equations.